Okay guys, today we're going to keep working with logarithms and we're going to do something called properties of logarithms. We're not going to be solving equations today, we're just going to be working with expressions probably for the next couple of days, and then we'll get back to equations after this because they kind of tie in. But there's basically three properties of logarithms that you're expected to learn how to work with, and they are very similar to properties of exponents that we already know. Now there are like 7 or 8 properties of exponents. The main three were the product property, the quotient property, and the power property. So quick review: when you multiply like bases that have powers, you keep the base and add the powers. So like if you had over here a squared times a to the 5th, it would just be a to the 7th. You add those powers. With the quotient property, if you have like bases that are divided and they have powers, you keep the base and subtract the powers. So example over to the right, x to the 6th divided by x to the 4th is going to be x to the 2nd, because you do 6 minus 4. And then the power property, when you have a base raised to a power raised to another power, you keep the base and multiply the powers. So over here on the right, p squared to the 3rd is going to be p to the 6th. 2 times 3 is 6. So those are properties you already know. We've worked with them off and on at various times in the school year. There are more, but nothing right now that we're going to deal too much with. When it comes to logarithms, there are 3 properties: the product, the quotient, the power. Looks kind of familiar. The product property for logarithms says this: if you have 2 logs with the same bases that are added together. Now I'm using the common log here. You can assume that it's base 10 and base 10, but you normally don't write that in. But it could very easily be base 2, or base 5, as long as they're the same base. I'm just not going to dwell on that right now. Just assume the logarithms match. So, okay, if you have 2 matching logarithms that are added together, you can convert it into one logarithm. You take the arguments of the logarithms and multiply them together. So it's kind of like this plus sign turns into a times sign, and it goes from 2 logarithms to 1 logarithm. For the quotient property, if you have 2 logarithms that are subtracted, you can condense it into 1 logarithm, and the arguments, the a, b here, they get divided. A divided by b. So it's like this minus sign sort of turns into a divide sign, and the 2 logarithms become 1. And then finally, the power property. If you have a number multiplied by a logarithm, you can actually take that number and make it a power on the argument. So the product property, for an example, let's say we had log base 5 of 6 plus log base 5 of x. You can turn this into log base 5 of 6 times x. That's the product property. I kind of got close to the edge, so give me a second to move this over. There we go. And I'm going to make that look a little bit more realistic. There we go. Okay, so for the quotient property, let's say you had log, we'll just do base 10 log. So a common log of w minus the common log of r. That would just be the common log of w divided by r. The third example, let's say you have 4 times the natural log. This works for natural logs too. 4 times the natural log of m. You can convert this to natural log of m. What was that? Cursive? M to the 4th power. So those 3 properties are what we're going to be working with today. Now you can do 2 things with these properties. What I just did is called condensing. So you can condense. But you could essentially start on this side and work backwards, and when you do that, it's called expanding. So you can condense or expand. Today we're only going to condense. That's all the assignment is based on, is that. But tomorrow we'll get into the expanding. Okay, so let's look at some of these even problems. Number 2. Now all of these problems are going to have at least 2 steps, maybe more. So we have 3 times log 7 base 7 of x plus 15 times log base 7 of y. Now, it's important the bases have to match, but they're always going to match. Otherwise, they wouldn't be homework problems. So don't worry too much about that. Just know that they're supposed to match. Okay, the first thing I'm going to do is the fact that both of these logarithms have numbers multiplied in front of them, I'm going to use this power property because it's the one that starts out with a number multiplied in front of the logarithm. So basically, I can change this into log base 7 of x to the 3rd power plus log base 7 of y to the 15th power. So right here, I just used the power property. And what I think I'm going to do is I'm going to go ahead and write a little side note next to every step so that you can see, if you want to look back at this, what happened each step of the way. All right, next I see a plus sign in between these two logarithms. That looks like this one here, the plus sign. So I'm going to use the product property to combine these together. So I'm about to use the product property to change this into one logarithm, log base 7, and you just take this x to the 3rd, y to the 15th, and multiply them together. X to the 3rd times y to the 15th. And that should be the answer. I'm going to scroll down to check it. I meant to make this 2 pages, and I accidentally made it 3, and that's going to kind of make it suck for you to upload this, maybe. I don't know. Sorry about that. And here it is. Now, they have y to the 15th, x to the 3rd, instead of x to the 3rd, y to the 15th. It's the same answer. It's right, so we're good. Also, you don't have to put the dot for times. So here, that's good. All right, let's look at number 4. 4 is just like number 2, honestly. We have coefficients or numbers multiplied by each logarithm. So I can make this log base 8 a to the 20th plus log base 8 b to the 5th. And then that plus sign there means that I can combine this. What am I about to write? Blog? I don't know. Can combine this into log base 8 of a to the 20th, b to the 5th multiplied by, together. Again, you don't need a little time sign there, but that's it. All right, let me check number 4. A to the 20th, b to the 5th. Yeah, and they did it backwards. I have no idea why they're doing that. Makes no sense. Don't worry about it. Okay. Number 6. So kind of like the last 2 problems, we start out with numbers in front of each logarithm. So we can use, what did I not do here? I did the power rule and I did the product rule. Said I was going to do that, and then I didn't do it. Okay, for number 6, I'm going to start again with the power rule. I'm going to put this log base 6 x to the 36th minus log base 6 y to the 6th. Now I have minus here. So if I look back at my 3 properties, the one with the minus sign right here is called the quotient, and that's the one that turns into a fraction. So we can combine this into just one logarithm with a fraction bar. The first one goes on top. The second one goes on bottom. Here the order does matter. With multiply, not so much. A times b and b times a is the same thing. But with divide, you can't switch the numerator and denominator around. That matters. So this should be the answer. This was the quotient rule, by the way. Let me scroll down and check number 6. Yep, exactly right. And let's look at number 7. So number 7, here, put this in your temporary short-term memory. It's going to be log base 2 of x to the 4th over y to the 12th. Let's see if we can get there from here. Okay, so I can start out with the power rule by making log base 2 of x to the 4th minus log base 2 of y to the 12th. Then I can use the quotient rule, x to the 4th on top, y to the 12th on bottom, and that is the answer that we were looking for. And that was the quotient rule. So this is called condensing because we start out with more than one logarithm, and when we're done, there's just one logarithm. Every one of these problems, when you're done, there should be only one logarithm. And again, that's condensing. Okay, number 10. All right, before we do number 10, there's something that happens. It happens in number 10. It's going to happen in a few other problems where you end up with, you're starting off with a logarithm that's being divided by a number. And here you just kind of have to know something about arithmetic. This has nothing to do with logarithms or algebra 2 or anything. It's just a fact that when you divide by 3, that's equivalent to multiplying by 1/3. Just like multiplying by a half and dividing by 2 give you the same thing. Whenever you divide by a number, it's the same as multiplying by a fraction. And the reason that's important is because none of these properties up here say anything about, being divided by a number, but we do have this third one that says, when you multiply by a number, you can do something with it. You can make it a power. So if we take this and change the divide by 3 into a 1/3, now we can do our first actual step, which is the power rule. So the power rule, or power property, we're going to take this 6 in front of the log and make it a power. And then we're also going to take that 1/3 and make it a power. Whoa. Getting a little confused with my 9s and my A's here. Okay, so now we can use the product rule to combine these together. What tells me that it's a product rule is the plus sign. So I can make this 1 log base 9, and then I multiply c to the 6th times a to the 1/3. But we're not going to stop there. There's one extra thing, and it's kind of the thing we just finished learning about before this whole virus thing kicked up. And that is, what is a fractional power? So in case you forgot, a fractional power is the same thing as a root. A to the 1/3 power is the cube root of a. Technically, cube root of a to the first power. Remember, the bottom number is the root, and the top number is a power. But when you have a first power, you don't really have to write it down. So that should be the answer when I go down to check number 10. Where is it? Yep, right there. So we're doing good. And if you look, a lot of these answers have roots, so this is going to be a recurring theme. So number 12, I'm not going to use any of the logarithm stuff yet. I'm just going to rewrite the problem like this. The divide by 2 turns into a 1/2, and then this one also turns into a 1/2. Okay, so now I can start. I can use the power rule. Now there is no number in front of the first logarithm, so that's not going to change. You could say, well, there's an invisible 1 there, but yeah, if you make that into a power, it doesn't do anything, so we might as well not even worry about that. Okay, so next, this is going to be log base 8 a to the 1/2, log base 8 b to the 1/2. So the power rule turns both of these coefficients into powers. Next, plus sign. Plus sign means product rule, but we have 2 plus signs. So what do you do here? You still combine it into one logarithm. You just multiply everything together. C a to the 1/2, b to the 1/2. You can put the little dots for times if you want, but you certainly don't need them. And then finally, the c doesn't really have a power on it or anything, but the a and the b both have a 1/2. Remember, a 1/2 power is the same thing as a square root, so we can just put the a and b both together underneath the square root. You don't put the 2 there typically. I mean, you could, but you generally don't. And again, the numerators of a 1 means there's a first power, but you don't have to write that either. That's just the answer. All right, let's check number 12. C square root AB. C square root AB. There it is. 2 more and we're done. Condensing logarithms. All right, 14 is a lot like 12, except they're all divided by 2. So, what did I forget? Up here, this was a product rule. Okay, 1/2 log 3 of x plus 1/2 log 3 of y plus 1/2 log 3 of z. When you do enough of these, you look at a problem like this, you can just sort of get the final answer like that, just blurt it out without working anything. But I'm going to show the work. So I'm going to do the power rule first. That 1/2 becomes a power, and it does that on every single logarithm. So we got that. Now we have plus signs, so we can use the product rule to combine them all into one logarithm, log base 3. And it's just x to the half times y to the half times z to the half. Put the dots if you want, you don't have to. And then finally, what is a half power? A half power is a square root. So that is the answer. Since all three of them have a half power, you put all three of them under the square root. If only two of them had a half power, I'd only put the square root over the two of them that did. Let's check number 14. Now, why did they do zyx instead of xyz? That makes no sense. All right, let's look at 16 before we go up. So we should get cube root CBA, or I bet I'll do ABC, whatever. That's what we're looking at for the final one here. Okay, so each one's divided by 3. That's the same thing as multiplying by 1/3. Now, each one of these coefficients, the 1/3, we can use the power rule to make all of those powers. So that's a to the 1/3, b to the 1/3, and c to the 1/3. All three of these plus signs means the product rule. So log base 8 of a to the 3rd times b to the 3rd times c to the 3rd, 1/3, not third. A to the 1/3, b to the 1/3, c to the 1/3. And of course, 1/3 power is the same thing as a cube root. Since all three of them have it, all three go under here. And yeah, to me it makes more sense to put ABC, not CBA, but whatever. Okay, your homework problems are going to be very similar to these. Some differences, but a lot of things the same. The quotient rule doesn't come up as much, so that's okay. But just do your best shot at trying this, get it down, get the concept of condensing down, and then tomorrow we'll get into expanding. As always, email me or leave comments if you have questions. This is also a topic where if you were to go into YouTube and just type in rules of logarithms or properties of logarithms or laws of logarithms, you'd find lots of tutors explaining in detail how to do these as well. So good luck. Let me know if you have trouble, and have a great day.